Okay, so here's how we're going to use this table. Okay, this table is just a mental way for you to sort of visually walk through all the different options that we have to solve. You will not be able to use this flowchart on your test. Okay, so students often say to me, Mrs. McKinney, how do you know what way to solve? Okay, the reality is, just like when you see an equation that you need to solve now, right? If you're solving a 1 or 2 step equation, you don't have to think about it, you just know what to do. Okay, when you've done it enough times and you've walked through the process enough, you just sort of look at it and you just sort of know. Okay, but we're not quite there yet. Okay, and these are sort of the pieces that I think through in my brain so quickly that I don't even have to think about it anymore. It just sort of naturally happens. This top left-hand corner box that's in bold is the place that you will start every single time. So if you are given a problem, the first thing that you will do is you will look at the problem and you will ask yourself, is there an x to the first power in the equation? Now I'm using x to the first power loosely here because it could be a y to the first power or w to the first power or whatever. If we see an x to the first power, we'll say yes and we'll follow this line. If we say no, we will follow this line. Okay, so over here, let's say we were given the problem x squared minus 20 equals 5. Okay, let's say that problem was given to us and we were trying to decide how to solve. The first question that we would be asking ourselves, is there an x to the first problem in the equation? So if we look at this problem, do we see an x to the first power? No. So we follow the no line. It says solve by taking a square root. Okay, so when we solve by taking a square root, we just want to do that inverse operation to get x by itself. So how do we undo subtracting 20? We add 20. $20 plus 5 is 25. Okay, we will then square root each side. What is the square root of 25?
5.
What is the square root of 25? Plus or minus 5? I definitely think that that's an option you should be using and considering. No one should be saying, I'm not going to solve by taking a square root. Okay, it's too easy, it's too quick, we could all handle doing that. Okay. Now, if we say the answer to that question is not no, but instead yes, the next question we would then ask ourselves is it a binomial or is it a trinomial? Okay, if it is a binomial, we're going to factor out a GCF and set each factor to 0. Okay, so now again, over here in this space, let's say we were given the problem 3x squared plus 6x equals 0. Okay, so if we look at this problem, is there an x to the first power in the equation? Yes, right? Right here, x to the first power. So we follow the yes line. Is it a binomial or is it a trinomial? Binomial. So we are going to factor out a GCF and set each factor equal to 0. Okay, so we're factoring out a GCF. What goes into 3? That will also go into 6. 3. Do they both have the variable? Yep. Smaller one is x, so we can factor out a 3x. Okay, so this factors into 3x times x plus 2 equals 0. And we can then set both of those equal to 0. So I can say 3x equals 0. And I can say x plus 2 equals 0. So we'll get answers of x equals 0 and x equals -2. This is also an option I really think that we should be considering and using. Okay, after this point, we start to have a lot more variety of who might choose what where. Okay, but these two are pretty straightforward. And class, I'm going to be honest, these aren't even the end-all be-all, right? This first one, instead of solving by taking a square root, it's potential that it was a special case and you could solve by factoring there as well, right? There are always options. I'm just trying to put something down on paper for you to have a process to think through. Okay, if it's not a binomial, but it's a trinomial, the next thing we're going to decide is if a equals 1. So I'm going to start scrolling here. Okay, here's where there's going to be a large variety of preference happening. Okay, so does a equal 1? You're going to decide yes or no. And then you're going to decide if you can factor it as a trinomial. If you say, I like to solve by factoring, and I'm good at solving, or sorry, not solving, factoring trinomials, especially when a equals 1, so that's no rewriting and factoring by grouping, just straightforward trinomials, then this might be an option you want to use. If you're like, please, dear Lord, don't make me factor, I don't want to factor, you might be crossing this off your list and might not even consider this as an option at all. Okay, you might just be saying you're going down this way no matter what. Does that make sense? So you might be crossing off this portion of your graph and you might decide that you just want to go here. That's a preference. Okay, but so that we have examples of every category, let's say we were given the problem x squared plus 7x plus 12 equals 0. Okay, we're going to start from the very top corner of our chart. Does this have an x to the first power? Yes. Is it a binomial or a trinomial? Trinomial. Does a equal 1? Yes. Can we factor this as a trinomial? So can we think of multiples of 12 that will add up to 7? 3 and 4. So we could factor this into an x plus 3 times an x plus 4. And we could set both of those equal to 0. And we would get x equals -3 and x equals -4. Okay, now whether or not you decided to, right, you might have this adjustment on your table and you might be making your yes line here if that's your preference. You do not have to do that. Okay, either way we might lead to a problem that gets us over here. Okay, so maybe we're given something that says x squared plus 8x minus 5 equals 0. Does this have an x to the first power? Yes. Okay, is it a binomial or a trinomial? Trinomial. Does a equal 1? Yes, but we can't factor it, or we're skipping that step altogether. Is b even? Yep. So then we could solve by completing the square. Yes?
Wait, so when can't you solve by completing the square?
Oh, you could solve other ones by completing the square. It's just more decimals or fractions or a longer process.
Didn't you say like, isn't it like it's ax plus bx equals c?
Completing the square is x squared plus bx equals c, right? So if there's an a in front, we had to divide by it.
Because it needs to be. Okay.
So that's why I have this, does a equal 1? Yes, Donovan?
Didn't you say we could like always use the quadratic formula?
Yes, we're gonna get there. Okay, so we could add 5 here to the other side, because completing the square says it has to be set equal to c. What does b equal? 8. What's half of it? 4. What is 4 squared? So we're gonna add 16 to each side. That ends up being an x plus 4 squared equals 21. So if x plus 4 equals plus or minus the square root of 21, so if x equals plus or minus the square root of 21 minus 4. Okay, now I'm hearing the exact same, guys, I know we're getting close on time, but just give me a second here. You could decide every single time you want to use the quadratic formula, which means maybe you're crossing out all of your table and you're just going here. Okay, but the quadratic formula is definitely something we want to use when a isn't 1. It's not required. I mean, you could factor if it's factorable. You could deal with the fraction and completing the square. Just sort of an option to consider. Do we see how this flowchart works to help us decide?